So this is my discussion of my analysis of the sales data set that was provided for the real-time data analytics project. My name's Louise Finnegan and my student number is D00224819. In this screencast, I am going to be summarising briefly each section of the data, what I did, my thought process going through it, and the challenges that I experienced working through this, of which there were many. So what we started off with was reading the brief and getting the required code into R. So I started off, I looked at the packages and ensured we had the right packages. So I used the code that was given and put that at the start of the project. So the easiest part for me was probably reading the data into R. I used the tidyverse package for it, using the read_CSV. Having a look at the data initially, I saw some problems there that I've highlighted. You can see the tax at 5% and the gross income. They have same data, so we won't use gross income. You can also see gross margin percentage is the same number all the way down the columns. So we'll see if it can be fixed and work through from there. Also noted that most of the columns were characters, so I had to have a look at the format of them as well. So just a look at initial 1,000 observations, 17 variables, there's the categories, there's the types of data that's in each category. Initially I wasn't happy with the column names, looking at the principles of tidy data, spacing between the names, etc. So I just went through one by one and I tidied them up, have an underscore between them instead of spacing, took the 5% number out because that was going to cause trouble when I'm putting in the code. I changed this COGS to subtotal. I established that it was pretty much the cost of goods minus, or the total of the sales minus the tax at 5%. Looking at the data then, I was happy enough with the column names. I then moved on to looking at missing data. So this was okay for me because I have a lot of missing data in my final project. So I have been looking at how to deal with missing data, and I have also been researching imputing on data as well. So this section was reasonably straightforward. So first thing I did was I just checked to see what data was missing, but then I had a function that I could use and I established then what was missing in each column because a lot of the data was present in most of the columns, and then I had to look at dealing with the missing data. So initially I was looking at the tax column because the tax is 5%, and I was going to actually mutate columns and just multiply by 20 to get the costs of goods before the sale, so the subtotal, and by 21 to get the tax plus the value before tax. And then I've just said, right, as I was going, I was learning how to impute data, so I decided I'd just impute over it, and I just kept checking each time that I had the data each time. In the end then, as you can see, there's no missing data at all in my columns. Then I looked at the column types. So I didn't bother doing anything with the invoice because it was just an identifier for me. The date was a character, and I knew because there's time series to do, I'd have to look at doing that. Initially, I just looked on Stack Overflow and found a way of changing it from character to a date. I then had to do more with it as time went on. Then I started looking at changing variables. So I changed city to a factor, branch to a factor, the customer types to factors, product lines, and so on down. I then just checked the data to see what they were. So I found this glimpse function in tidyverse that's very similar to doing the string, and I used that instead. Then I just decided I'd tidy up the column, so I took out invoice number, I took out the gross margin percentage because as discussed is the issue, and I took out the gross income, and I just tidied it up and I ordered the data in a better format to what I would like it to be, and then that's it there detailed. Then I decided to start doing some descriptive statistics. So initially for me, I just wanted to find out what was in each column. So I did some univariate analysis and established we have 3 different branches in 3 different cities. We have types of customers. It was very balanced. I think it was out by one or so on each one. Looked at the sales, looked at the product lines, discovered there were 6 product lines. Then I looked at the unit price to see the distribution, done a box plot. Became very good at doing GG plots as I went, and I found as I went on as well that they got easier to do. For some reason, the quantity table I couldn't get down to a GG plot, so I just had to do a bar plot in base R instead, just to do some descriptive statistics of it. Then I looked at the types of payment, looked at the sales, and then looked at the tax and the total. I probably could have avoided doing these because they're all the same, really, the same distributions, just numbers being scaled up or down. Then I looked at the ratings as well, and as you can see there's a distribution of all of my code as from that. Then I started looking at some multivariate analysis. So I started looking at the branch and the city, and I discovered that the branch and the city pretty much meant the same thing. So I decided to remove one of them. So in the end, I removed out the city and proceeded only using the branch. As you can see, the sales are quite similar across all 3 branches. Branch A has a little bit more invoices than any of the others. Then I started to look at the customer type and gender, which I found quite interesting. So we could see straight away that we had a customer type. So I'll just go down here just to have a look at this. So we could see first of all that we have customer types by gender. So we can see straight away that we have slightly more females are members than males. So then we had a look at by their customer type and their gender across the branches. And again, you can see there the females are more, there's more members that are females than males. And you can see then across the branches as well that we have a lot of members in branches branch C that are female and branch A that are female, not so many in branch B. Branch B might be a growing branch, for example, if we do some more research on that. We can see then that a lot of members are also or a lot of customers are also normal customers as well as we go, but females tend to be more likely to be a member than a male. Then I decided to look at the sales by the customer type. And again, we can see straight away that members have a slightly higher median spend compared to a normal customer. So perhaps that's something again to be looked at to see, do members encourage more members to join because they're going to spend more. Then I looked at the sales by the customer type. And again, you can see there that members the members tend to spend more. There's a bigger distribution of member sales if you're female compared to male. Now the female median for members is slightly lower, but for males it's considerably higher. So perhaps more males need to sign up to be members because there's a big difference in the median spend. Then I looked at the ratings by the gender and the customer type as well. So this was quite interesting. So looking at the box plots, we can see that there's a bigger distribution in the ratings of the interquartile range in general if you're a member, and if you're female, compared to any of the others. We can also see then as well that home and lifestyle doesn't seem to be rated much by female non-ordinary customers compared to members, and a few others there, for example. Then I looked at the product types and values and ratings. So this is just very much just have a look and see what's happening in the column with the products. So I looked at the product lines at each branch, how many invoices were there for each one, and we can then see that food and beverage is very popular in branch C. We can see that home and lifestyle is very popular in branch A. We can see fashion accessories quite popular in branch B and C, not so popular in branch A. And we can then see health and beauty is amongst the lowest of the popular items in general across all of them. Then I looked at the total value of sales by product type. So we can see there that the sales by product type, the most popular sales is clearly food and beverages. The least popular is the health and beauty. Going down further, I'm going to try and speed this up, looked at the methods of payment. So we can see that a lot of the payment types at each branch, so we can see that the most common payment type does tend to be among members. Cash is a very popular payment type across the board, so it is. We can see from that. Then we're looking at sales across the different product types. So I had a bit of a look to see what was most popular by each gender and the distribution of the spend by the product and the payment type. So we can see a distribution there, and we can look at the spend. We can see that credit cards are very popular in spending for so it is for electronic accessories. That's the biggest distribution of spend. E-wallet also. Cash buyers tend not to spend so much on electronic accessories. We can see from there too. Going into ratings of products, again, just had a look at see what the story is. We can see there that the ratings across the product lines, it does vary a lot between the branches, so it does. That was very clear. We can also see huge distributions there, which is all discussed. Then looking at the value of the sales. So this was very hard for me. I found I do know I need to improve on looking at lubricate. Just getting a look at data and getting the time. So I figured out a way to have a look at the sales and making a GG plot for looking at the sales over a time period. I've done that by gender, and then I've done it at the total sales as well, and I've done a few pipe operations as well to see. So a couple of things that I looked at by day of the week. Each branch has a particularly busy day. Branch C, we can see the busiest day for sales is on Thursdays, followed by Mondays. We can see that Mondays is quite busy in branch A. I also then looked at the value sales across the branches and product lines. And I also looked at over time what's happening to the products, which is again, I featured this in time series, so I'll discuss it there. Also looking at total value of sales by days of the week across all three branches together as well, so we can see that Monday is the most lucrative day. K-means clustering was quite difficult to observe on the elbow. It was a bit of trial and error. I came up with 4 clusters there as discussed in my report. Time series I found very, very difficult, and I know this is an area that I am going to have to practice with. So I initially started looking at converting everything into the correct format. I knew I needed to total up things by product lines as well. So I got working on that, but again, I found it very tough. So I aggregated all the totals by the week number and the product line after I created a new column called week number to look over time. Then looking at the sales by the product line, we can see it there. It's a bit of a time series done in GG plot, so I know I have to pull it out one by one now. So I specifically picked the product line as being electronic accessories, and then I looked at the sales each week for electronic accessories. Then I created that as a data frame before I created my time series. I tried to do a sub-series plot, but the data series was too short to use, and that was the warning that came up in OR. Managed to fit them, but my forecast, for some reason, I can't get that figured out, and I think it's something to do with lubricate, so that's something that I know I need to work on. Again, food and beverages, the same thing happened again. I just couldn't get the forecast to work, but everything else pretty much went. Again, time, home and lifestyle, similar again. I couldn't get the forecast to work, but I managed to do the autocorrelation and partial regressions as well, and looking at the residuals. I managed all that fine. I'm going to probably run out of time now. There's my descriptive